Lecture 5 of 5, still differentiation, 9.5 parametric differentiations. Okay, objective for this lecture, solve the first and second parametric derivatives for this lecture. And then what is parametric equations? Parametric equations are the equations where x and y are both given as functions of a third variable, that is a, all as a parameter. Example, x equals t squared, y equals t minus 1. X in variable t, parameter t, y in parameter t. And parametric differentiation, if x given in t variable parameter and y given in t, then by using the chain rule we can determine dy dx. Okay, dy dx equals dy over dt, dy dt times dt over dx or dt dx. Then dt over dx is equal to 1 over dx dt. And dy dx is equal to dy dt over dx dt. Okay, just remember this formula or this. Okay, second order derivative with d to y dx squared, that is differentiate dy dx with respect. Okay, then dy dx in parameter t. So before can differentiate this one in parameter t, you need to change to variable t or that dy dt, differentiate dy dx with respect to t times dt over dx. Okay, this one. Okay, dy dx in variable t or parameter t. Okay, you need to differentiate with respect to t before can differentiate this. Okay, this is in variable t. Okay, differentiate with respect to t, but times dt over dx. Okay, let's say if we cancel dt stay the same one. Okay, and d to y dx squared is equal to, okay, d differentiate this one with respect to d, differentiate dy dx with respect to t over dx dt. Over dx dt. Okay, this one you need to remember the formula. Example 1. Find dy dx and d to y dx squared in terms of the parameter t if given x is equal to 2t cubed, y equals 4t squared plus 1. Hence, okay, find the value of dy dx, d to y dx squared if t is equal to 1. Firstly, you need to find dy dx and d to y dx squared, and after that substitute and find the value of dy dx and d to y dx if t is equal to 1. So the next we try to discuss this one to find dy dx and d to y dx. Okay. Okay, write d dt d dt. Okay, d dt. Okay, differentiate x with respect to t, differentiate 2t cubed with respect to t. So dx over dt can be cancelled. And this one use power rule, 6t squared. Okay, dt over dt can be cancelled. So for this one, differentiate y with respect to t can do directly. dy dt is equal to 8t. Okay, you can skip this step. And to find dy dx, okay, dy dx Okay, dy dt times dt dx, or dy dt over dx over dt. Then substitute dy dx 8x, okay, and dx over dt 6t squared, okay, and then 8t over 6t squared, and simplify 4 over 3t. So this is dy dx. Okay, the next step, we're going to find d2y dx squared. Okay, to find d2y dx squared, the formula is d2y dx squared is equal to d dy dx. Okay, this one need to respect to dt and dt over dx. Okay, and then substitute dy dx. This one, dy dx, substitute. So d dt there is 4 over 3 and bring up power negative 1 dot d dx dt over dx. So that's that. Okay, you need to differentiate. You need to differentiate this one. Okay, so differentiate constant 4 over 3 and negative t power negative. Then for this part, okay, for dt over dx, okay, actually this is 1 over dx over dt. 1 over 6 times 6t squared. Okay, and simplify negative or negative, okay, 4 over 3t squared dot 1 over 6t squared. The answer is negative 2 over 9t to the power 4. Okay, this is for d2y dx squared. Okay, here for this part, okay, so you need to differentiate because this is not still not complete. You need to differentiate this function in parameter t with respect to t. So for this part, you just take this one, the value, and substitute. No need to differentiate because all this is already done. Okay, after that, hence find dy dx d2y dx squared when t is equal to 1. Okay, t is equal to 1. So substitute dy dx 4 over 3, 1 is equal to 4 over 3. Then for this part, and for d2y dx squared, substitute here. Substitute negative 2 over 9, 1 over 4 is equal to negative 2 over 9. Okay, and done for this example. Okay. Okay, this is the second derivative. And then okay, simplify, get negative 2 over 9 power 4. Okay, and then substitute when t is equal to 1, dy dx is equal to 4 over 3, and t d2y dx squared, okay, substitute t equals 1, and the answer is negative 2 over 9. Example 2, even x is equal to ln function, y exponential function, find dy dx d2y dx squared in terms of t. Okay, and then okay, now okay, here is okay, we need to differentiate with respect to t. Differentiate x. respect to t. This is ln. Okay, bring down 1 over t cubed, and you need to differentiate here, the denominator. So 12 t power square because of 3 minus 1. And then simplify. Okay, 3 over t. Okay, and for y, differentiate y with respect to t here. And this is exponent, copy, on the equal. Differentiate. Okay, 3t, get 3. And answer is 3e power 3t. So now, using the chain rule, dy dx is equal to dy dt, okay, times dt over dx, or dy over dt over dx over dt. And then substitute dy dt here, 3e power 3t over dx dt here, 3 over t. Then simplify and then bring t up, so and cancel t. Answer is t e 3t. Then for dy dx. Now we're going to find d2y dx squared. d2y dx. Okay. d2y dx squared, you need to differentiate dy dx ni, this one here, with respect to t e power 3t with respect to t, times d e over dx, or 1 over dx over dt. Why? Because of the formula is d2y dx squared is equal to differentiate dy dx with respect to t dot dt over dx. Yes, if you cancel this one, you get the same one, d2y dx. Okay, and the next step here, okay, here you need to differentiate this. This is t times e power 3t. That is consider, concentrate this one. Okay, you need to differentiate d, okay, t e power 3t with respect to t. There is, here is two different function, u, v. Okay, u is equal to t, v is equal to e power 3t. And u prime is equal to 1, v prime is equal to e power 3t, differentiate 3t, get 3. Okay, one is different u equals t, differentiate u with respect to t. That's why get du dt is equal to dt over dt is equal to 1. Okay, and the next step, you apply product rule, and y equals uv y prime u prime v plus uv prime. Okay, now because of this is uv, just this one, uv on the right hand side. Okay, is equal to 1 times e power 3t plus t 3e power 3t, and factorize e power 3t, get 1 plus 3t, and substitute. Okay, here substitute here. Okay, so is equal to e power 3t times 1 plus 3t over, okay, dx, 3 over dx over dt, 3 over t. Okay, simplify, bring t up, so t e power 3t 1 plus 3t over 3. That is the answer for this. Okay, 1 over 3 t e 3t plus times 1 plus 3t. So done for this example. Okay, dx dt, dy dt. Apply chain rule. Okay, and then get dy dx is equal to t times e power 3t. Okay, from the info, find d2y dx squared. Okay, so for this one, you need to differentiate for the second time, and using the product rule, this product rule, and simplify, then get the answer. Okay, so for example 3, okay, given ratio x equals to 0 and y also ratio, show that dy dx is equal to this, and find the value dy dx at point. This is x, this is y. Okay, hence find d2y dx squared and y is equal to negative 2. Okay, we're going to do first and show that dy dx means we need to differentiate x with respect to t, differentiate y with respect to t, apply chain rule to find dy dx. Okay. Okay, from the ratio, okay, bring up. So find dx over dt. Okay, power rule, negative 2 bring to front, negative 4, 1 minus t. Okay, negative 2 minus 1, negative 3. And differentiate whatever inside here. So negative 1. Okay, simplify. Negative 4, negative 1 is 4 over 1 minus t cube. Okay, this is dx dt. Okay, for dy dt, okay, differentiate negative 1 constant 0, and differentiate negative 1 bring power rule, negative 1, and 1 minus t, negative 1 minus 1, negative 2. Then differentiate inside here, negative 1. Simplify. So 1 over 1 minus t. Okay, this one is dy dt, this one is dy dx. Okay, now we're going to show the dy dx. Okay. dy dx now is dy dt is equal to 1 over 1 minus t squared dx over dt is equal to 4 over 1 minus t cube. Okay, so dy dx is equal to dy dt over dx dt. Okay, and substitute. Okay, dy dx is equal to 1 over 1 minus t squared over dx dt is 4 over 1 minus t cube. And simplify. 1 over 1 minus t squared times 1 minus t cube over 4. And then simplify, answer is 1 over 4, 1 minus t. And check, oh, this one is shown. Okay, show like this, right, and shown. Okay, settle for dy dx. Okay. Second is find dy dx at the point 2, negative 2. Okay, this is x value, y value. So now dy dx is equal to 1 over 4, 1 minus t. So we're going to find dy dx, the value of dy dx. So this is variable parameter t given in x and y. So we need to find t from the given points. Okay, so check the first equation when x is equal to given 2 over 1 minus t squared, y is equal to t over 1 minus t. Okay, and now given, okay, x is equal to 2. Okay, x is equal to 2. Substitute, okay, and find value t. 1 minus t square. Okay, bring up 1 minus t square 1. 1. Okay, and expand, this is quadratic expand. Okay, 2t plus t squared equals 1. And t squared minus 2t is equal to 0. Factorize. So, t is equal to 0 or t is equal to 2. Two value for t when x is equal to 2. So, what happens when y is equal to negative 2? Okay, negative 2, substitute negative 2. And then equals t over 1 minus t, bring up, negative 2 plus 2t is equal to t, and therefore t is equal to 2. And check, oh, this is 2 and 2. Take the common value. Okay, overlap value means that therefore t is equal to 2. At this point, t is equal to 2. And substitute this value, substitute, and 1 over 4, 1 minus 2. Okay, and then 1 minus 2 is equal to negative 1, so answer is negative 1 over 4. So this is value for dy dx. Okay, okay, at point 2, negative 2, x equals 2, and t to answer 0 and 2, and y is equal to negative 2, and t is equal to 2. So common value is 2. Okay, substitute, and the answer dy dx is equal to negative 1 over 4. Okay, now we're going to find d to y dx squared when y is equal to negative 2. Y is equal to negative 2. It implies that t is equal to 2. Okay, so t is equal to 2. Okay, y equals to 2 means t is equal to 2. So now we're going to find d to y dx squared. D to y dx squared is equal to, the formula is d need to differentiate dy dx with respect to t times dt over dx. Okay, then substitute d dt, and here is dy dx is 1 over 4, 1 minus t, and dt over dx, okay, is equal to over dx over dt. Differentiate this one. Okay, inside here is linear, differentiate. So 1 over 4, okay, differentiate 1, constant 0, differentiate negative t and negative 1 over dx dt is 4 over 1 minus t cube, and simplify. Okay, negative 1 over 4 times 1 minus t cube over 4, and okay, simplify 1 over 16, 1 minus t. Okay, that's still not finished. Because of t is equal to 2, you need to substitute. Okay, you need to substitute t is equal to 2. Okay, when y is equal to negative 2, t is equal to 2. Okay, and that it implies that d to y dx squared is equal to negative 1 over 16, 1 minus 2 cube, 1 minus 2, negative 1 cube, negative 1, negative 4z. So the answer is 1 over 16. Okay, settle for this example. Example 4, find dy dx if x in parameter theta trigo function, y and theta parameter trigo also, Then you need to differentiate this. Okay. Then differentiate. Okay. X with respect to theta. Okay. Parameter is theta. Before that, expand. Expand. X is equal to 2 theta plus 2 sine theta. Y is equal to 2 minus 2 cos theta. And differentiate dx over d theta 2 theta. Same like you differentiate 2x, that 2 plus 2 differentiate sine theta, sine that cos theta, and differentiate y with respect to theta. Differentiate to constant 0 and differentiate cos. Cos is negative c, shows that this is negative. Differentiate, okay, differentiate cos at sine, so negative sine theta, and then this is 0. So negative, so 2 sine theta. Now we're going to find dy dx. Okay, using chain rule. Okay, dy dx is equal to dy d theta, that d theta over dx, or dy d theta over dx over d theta. So substitute. Okay, 2 dy d theta, take this one. Okay, 2 sine theta over dx d theta, take this one. 2 plus 2 cos theta, and simplify sine theta over 1 plus cos theta. Okay, so settle for this example. Okay, chain rule and done. Example 5, given that x equals still trigonometry, y equals this one, trigonometry, show that dy dx is equal to negative cot 2t. Okay, here x, okay, x is equal to sine 2t cube. Okay, change to sine 2t, okay, cube. Okay. And then differentiate x with respect to t. Okay, use a from outside, differentiate from outside to inside. So alternate from outside to inside. So 3 squared, 3 minus 1 squared. So write whatever inside. Then you need to differentiate sine that cos 2t. Then differentiate 2t that 2. Okay, from outside to inside, outer to inner, so alternate. And then 6 sine 2t squared cos 2t. Okay, settle for this one, this part. For y equals cos 2t cube. Okay, write in this form, cos 2t cube. So from outside to inside, alternate. Differentiate y with respect to t. Okay, here is cube. Okay, using the power rule, and this one is 3 squared, and then cos 2t. Differentiate cos c negative, sine 2t, and differentiate 2t, get 2. Answer is negative 6 sine 2t cos 2t squared. Okay, now we're going to find dy dx. dy dx. dy dt dot dt dx, or dy dt over dx over dt. So now going to find dy dx. Take this one, dy dt dy dt is negative 6 sine 2t cos 2t squared, okay, over dx dt. Dx dt is this one, okay, like this. And then it is 6 sine 2t squared cos 2t. Simplify. Okay, we cancel 6 negative. Okay, cancel. Here cancel. Cancel. And negative cos 2t over sine 2t. Okay, and is equal negative. Cos over sine is cot 2t. Done. So soon. Settle for number example 5. Conclusion. If x is equal to in parameter t, y in parameter t, then by using chain rule, dy dx equals dy dt times dt dx. Okay, or dt dx is equal to 1 over dx dt. Okay, or just remember that dy dx is equal to dy dt over dx dt. And then for the second derivative, d2y dx squared, okay, differentiate dy dx with respect to t over dx dt. So that's all for this lecture, and then done.